Hey guys, let's do this problem right here. It's asking determine the internal shear force and moment acting at point C in the beam. So let's see how we can do this. So first of all, I would like to put the forces acting on it. So this one has only one possible force, that's going to be vertical force, and let's say this is By, and this one possibly can have two forces. One is vertical and horizontal. So this is Ay and Ax. So from this diagram we know we can take the moment around A and find the B. But however we have a distributed force acting on top, so we have to find the exact force for this one. So to find that I have to multiply this 500 by this distance. So if I multiply I will get 500 times 12, which is going to give me 6,000. So 6,000 pounds is going to act exactly in the middle. So let's say, so I have to erase it, and put that value. So middle of this distributed force is going to be in the 6 feet. Since this is 12, so exactly in the middle, so it's going to be 6,000 right here, 6,000 pounds, and that's all we need to know. From now I can calculate this Vy by taking the moment around A. So if I take moment around A, and this is going to be 0 in statics, and if I take the clockwise and solve for this one, this is going to be negative because this is acting counterclockwise, so it's going to be minus 900. And also we have this for 6,000 pounds, so plus 6,000, this is acting clockwise, that's why it's plus, and 6,000 times this distance is 6, and then we have another moment created by By, it's acting counterclockwise, so it's going to be negative By times the distance is 12 feet from the A, so it's going to be 12. Then we have another 900 acting clockwise, so it's going to be positive 900. That's a moment, so we can directly put it. So it's going to be 900 from this is equal to 0. So 900 cancels each other, and 12 By is going to be equal to 36,000. Therefore, By is going to be equal to 3,000. 3,000 pounds. And since the answer is positive, our assumption is right, this is the direction. And then from now on, our main focus is to find the shear force and moment acting on point C. So this is the purpose. So to find that, I have to cut this part off to do the method of section. So let's do that one. So if I cut this part off, so we have a By right here, but however this is not going to be the force acting on this one. We are going to have a new distributed force, but this time the distance is going to be just 6 feet. So let's draw the distributed force. So it's until By, it's continuing until By. So this is same 500 foot per pound, 500 pounds per feet, 500 pounds per feet. This is 6 feet. So to calculate also, we are gonna have normal force acting on it, and we can say shear force. So before I put the shear force, let's calculate the distributed force. So let's say this is 500 foot pounds per feet, and the distance is 6 feet. So to find the exact force acting on it, I had to multiply these two. So it's going to be 500 times 6, and if I say, okay, let's say Fy prime, and if I say like this is going to be 6 times 500, this is going to be 3000. So 3000 exactly in the middle of this object, so it's going to be at 3 feet. So therefore let's draw a new diagram with this force. I draw it here. So we are going to have By right here, and the new force Fy prime is equal to 3000 pounds exactly in the middle, so it's going to be 3 feet from each side. Then we are going to have NC, and we can just assume VC is in this direction and MC in this direction. It's all just the assumption. So now we can solve this picture. So let's take the f of x first. Horizontal forces equal to 0 in statics. Then if I take this direction positive and solve this one, this is going to be negative NC, and that's the only force we have on the horizontal axis. So this is equal to 0, therefore NC is equal to 0. Then if I take the vertical axis, so sigma Fy is equal to 0 in statics, and if I take the upper direction positive and solve for this one, this is going to be negative 3000, and we are going to have Vc in the negative direction and By in the positive direction, and By we have found out already, it's also 3000. Therefore these are the only forces acting on it. So from this one we can say this two are going to cancel, therefore Vc is going to be 0. Now I can calculate the moment C. So to calculate the moment C, I can take, since I assume this direction counterclockwise, I take this direction. So MC is equal to 0 in statics, sigma MC is equal to 0 in statics, and if I take this one, this is going to be positive MC, and the other force that's going to be created is going to be by Fy prime, that's going to be 3000 times, since this is clockwise, it's going to be negative 3000, the distance is 3 feet, so I multiply by 3, and then By is going to create a moment in the counterclockwise direction, so therefore this is going to be positive and the distance is 6 feet, so it's going to be plus By we have already found out is 3000 times 6 feet, and these are the only forces that create movement, therefore this is equal to 0. So from this 3000 by 3 times 3, and okay, let's calculate this one. So MC is equal to 9000, and this is gonna be 18,000, and if you calculate also, oh, we shouldn't forget there are also 900 foot pounds moment acting on this side, so 900 foot pounds. So since this is clockwise, I have to subtract this one too. So this is gonna be clockwise, therefore it's gonna be minus 900. So it's going to be 9000 minus 9000 plus 900 from 18,000. So it's going to be MC is equal to minus 8,100 foot pounds. So therefore, since the answer is minus, we know this is going to be opposite direction. Our assumption is wrong, and the direction is going to be clockwise. So we can say MC is equal to 8,100 uh, pounds or foot pounds. foot-pounds in the clockwise. So this is the final answer, and that's all we need to know. The main question is moment and the shear force at point C. So that's all we need, and I hope you guys like this video. See you next time.